Hi, my name is Rajamani Selvam. I'm a recent graduate and neuroscientist. I'm trained as a neuroscientist, but away from science, I like to enjoy traveling as well as painting. Today, I'm going to talk to you about my PhD research. So, to begin with my research, I want to give this example. Let's assume that you are an ice cream stand and you are buying your favorite ice cream. Let's say it's a chocolate ice cream on a cone. How many of you are able to recollect the memory? Have you ever thought about why you are able to recollect a memory when you don't have an ice cream in front of you? That's because you can remember when was the last time you had your ice cream, or you remember what was the first time you had your ice cream. And that's because of a process called learning and memory that happens in your brain. The brain region that's involved in learning and memory is called hippocampus, and it looks like a seahorse shaped on your brain. So I was particularly interested in this region of the brain. So the question is like, why am I interested in this region and what am I looking at it? So I was interested in this region because it contributes to learning and memory. Second, I was interested in a growth factor called brain-derived neurotrophic factor, or BDNF. I want to understand the role of this growth factor in hippocampus. The reason being that when there is a lack of BDNF or the growth factor in this area, then it causes some impairments in learning and memory. So now I have set up two things here. One is hippocampus, which is a brain region. Another is a growth factor called brain-derived neurotrophic factor. So what was my research question that I addressed in my thesis? I want to know what happens acutely when you just throw BDNF into these hippocampus. What does it do? In long term, yeah, it plays a role in learning and memory, but we do not know what it does even in acute level. So that was my research question I was trying to address. The way I did it, I used electrophysiological recordings. So what do I do, or what do I mean by it? These are acute mouse slices. I slice a brain and then I look at the hippocampal region by the shape of it. So it will be a seahorse shape under the microscope. And then I pick a neuron and I do electrophysiology on them. In simple terms, I pick a neuron and I poke the neuron with a glass pipette. So once I poke it, I have access to the interior of the cell and I measure the currents or the voltage depending on what I'm looking for from this neuron. So I also do BDNF as a bath application, which means that I patch my cell or poke my neuron and then I do the drug. In this case it will be BDNF or a growth factor, and I look at what happens to them. And I found that at least in inhibitory synapses, BDNF causes a decrease in activity. So in brain, if you think about it, you have two processes. One is excitation, other is inhibition. Excitation is a process by which you kind of remember everything, and inhibition goes in parallel with excitation. It's a balance that happens in the brain. It's kind of saying like good and bad, or positive or negative. That's what excitation and inhibition does in your brain, and you need both these parts to have a functional brain. So I found out that BDNF causes a decrease in inhibition in hippocampus. So when I've explored further, how does this happen? What is the mechanism that's causing it? We found a very interesting finding. We found that endocannabinoids is causing this kind of mechanism with BDNF in parallel in hippocampus. So let's talk about endocannabinoids. An easiest way to explain endocannabinoids is it's a component of marijuana. So it has its own recreational use. But why is it so important in the brain? Because it was first identified in the brain as a molecule that was expressed in the brain during an euphoria or a pleasure sensations. So once we identified these endocannabinoids in the brain, we also identified the receptors by which endocannabinoids plays a role. So I was particularly interested if endocannabinoids and BDNF are interacting, or what is causing this interaction. So as I said earlier, BDNF causes a decrease in inhibition in hippocampus, and endocannabinoids play a role in this. So my part was, how does this mechanism work? What's happening between BDNF and endocannabinoids? I found that BDNF, by some downstream signaling pathway mechanism, it causes the release of endocannabinoids, and the endocannabinoids then act on the inhibition. So it's not that BDNF is directly impacting inhibition, but BDNF uses an indirect mechanism. In this case, it's endocannabinoids to impact the inhibition. So that's the system that I found in my research, that BDNF does cause a decrease in inhibitory activity or in inhibition in hippocampus, and the way it does is it involves endocannabinoids. So that was the major finding of my thesis research. And if there's any take-home message that I want to give away with this talk, it's a growth factor, BDNF, interacts with a component of marijuana endocannabinoids at hippocampus to suppress or to decrease inhibition at these synapses. With that, I would like to conclude this talk and thank you for the time. Thank you.